So, now we are going to discuss about software defined networking and its use in IoT. So, here we are going to talk about how SDN can help in improving mobile networks specifically. So, what we have already discussed in the first part of SDN for IoT lecture is that we have sensor networks, and software defined networking can be used to improve the performance of sensor networks. So, we have different SDN approaches for WSNs and different approaches like sensor open flow, soft WSN, SDN wise are already available in the literature, which can be used. Community can use it if they want to implement SDN for WSNs. And we have also discussed about how software defined WSN can improve the overall performance of the network compared to the traditional WSNs. So, this is what we discussed earlier. Now, let us talk about the traditional mobile wireless networks. There are different problems in these traditional mobile networks, and these networks can be like Wi-Fi based networks, mobile cellular networks or other mobile networks. The problems are with respect to scalability. So, what happens is each of these nodes in the networks, the nodes including the base stations, access points, etc., typically they are statically over provisioned. So, there is over provisioning in each of the nodes in these networks, and they are inflexible to manage the mobile traffic with high demand. They are difficult to manage, many times this leads to misconfigurations. They are inflexible, requires too much time to introduce a new service as a hardware architecture is inaccessible, and they are cost expensive both in capital expenditure and operational expenditure terms, because both the capex as well as the opex are very expensive, are very high. So, two things are important, and this information has been adopted from the Open Network Foundation. So, two things are important when we want to adopt SDN for mobile networks. One is the flow table paradigm of SDN, which is well suited for end to end communication over multiple technologies such as Wi-Fi, 3G, 4G and so on and so forth. The other one is the logically centralized control, which is particularly useful for efficient base station coordination for addressing intercellular interference. So, we are going to talk about each of these in slightly more detail in the next little while. Other issues which are also important are path management, which concerns basically data that can be routed based on service requirements without depending on the core routing policies, and network virtualization, which is about abstracting the physical resources from the network services. This helps in providing seamless connectivity and service differentiation among the users. So, in a traditional mobile network, what happens is when a mobile equipment like this operates, it connects with a base station or an access point for regular data, data back and forth between it and that access point, and this particular node, it serves this particular access point, this particular user equipment. But while it is doing so, it may also get affected by interference from another node. So, this red colored arrows basically shows the interference, and the blue colored ones basically shows the regular data transfer, data communication. So, there is this solution which is this SDWMN. It tries to address this particular problem of interference through the help of SDN. So, here what we see is the architecture of the software defined mobile network, and as we can see over here, we have an SDN controller and the virtualized radio resource management unit, which basically takes care of interference, with the problem of interference. So, this particular unit what it does is it takes care of issues such as the signals of E node B2 and the signal of E node B3, they do not affect each other. That means, the signal of E node B2 will not affect the signal of E node B3. Affect means through interference, affecting through interference. So, this is made possible through this virtualized radio resource management unit, which has been proposed in this particular protocol or the solution, which is SDWMN. And with respect to mobile traffic management, there is this unit which is the ANDSF, Access Network Discovery and Service Function unit, which basically takes care of it. And this is done this way. So, we have the cellular as well as the Wi-Fi and the mobility. So, basically what happens is when the user is moving, right. So, the user can get first connected to the regular Wi-Fi access point, then it might have better connectivity with the cellular network, 3G, 4G and so on. So, basically this particular solution basically takes care of it, how to interoperate between these different when the user is moving and is getting connected with and has different signals from different devices from different networks, Wi-Fi network, 3G, 4G networks, etc., how it is going to do this switching. So, SDN basically comes to a rescue to solve this particular problem. The key benefits of this solution is that centralized control of devices manufactured by multiple vendors is made possible. It is possible to have higher rate of integration of new services, and abstracted network control and management is made possible through this particular solution with the adoption of SDN in these mobile networks. So, when we talk about SDN and any SDN based solution, it is about rules, flow rules and rule placement, controller placement and so on. So, let us now look at how rule placement is made at the access devices in these networks. The challenges that have to be addressed are that number one, the general open flow does not support wireless network. So, because it is general open flow, it does not do that, some kind of a modification of the existing open flow is required. Number two, typically the users are mobile in nature and the network is highly dynamic. Third challenge that has to be addressed with respect to rule placement in these networks is that the frequent changes in rule placement is required, and the presence of heterogeneous devices in the network is a reality in these scenarios. So, basically what happens at the last point, what it says, the last challenge what it says is different types of heterogeneous devices having different configurations, supporting different vendor specific solutions and protocols and so on exist in a realistic mobile based IoT network. So, how to support such heterogeneous devices in a single platform? So, these are the challenges that have to be worked upon in order to deal with the rule placement issue. So, there are different approaches or different solutions that have been proposed for it. Number one is ODIN, number two is UBflow and number three is MobiFlow. ODIN basically proposes the use of an agent, it is an agent based solution, agent based architecture. So, here an agent is placed at the access points to communicate with the controller. So, this is the ODIN agent, and there is the ODIN master. So, we have the ODIN agent which is placed at the physical devices at the access point, for example, and the ODIN master which is placed at the controller. and now this is this handshaking between the communication between the Odin agent and the Odin master that is taken care of by this Odin protocol. So, it uses the communication between the Odin agent and the Odin master. The corresponding flow diagram, the flow chart is shown over here. We do not need to understand in detail, but it is given for those who might be interested to understand it nonetheless. And so basically it is a handshaking that goes on between this Odin agent at the access device and access point and the Odin master at the controller that makes Odin function. Now, let us look at the second solution, the UV flow solution, which was published in Infocom very recently, 2015, only 2 years back. So, here there are two main parts of this solution. One takes care of mobility management and the other one takes care of flow scheduling. Mobility management takes care of issues such as how to have scalable control of the access points, issues such as fault tolerance, that means if some component goes down then what happens, how can the network still function. And the other one is the flow scheduling, which has three parts. First is partitioning this entire network into multiple partitions, fragmenting this entire network into multiple partitions, and over here we have shown those three partitions through three different color shades: gray, light green and orange. So, we have three different partitions shown over here, network partitions, and after this network partitioning has happened, then network matching has to be done. So, let us say that this particular mobile device receives a particular packet. So, then what it is going to do? It is going to perform, it is going to execute this network matching algorithm. What that network matching algorithm is going to do is it is going to check that which of these network partitions should handle this particular packet. So, so then it will be sent to that particular partition for further handling, and load balancing basically takes care of it. So how the network matching and load balancing will be done together. So, load balancing is going to take care of issues such as that one partition should not get too much loaded while the other partition is underloaded and so on. So, this is what the load balancing is going to do. Now, let us look at the third solution that I was talking about, the MobiFlow, and this paper was published in IEEE Globecom 2016, and this is the solution. MobiFlow solution was proposed by us in the SWAN group, and the mobility. So, MobiFlow basically gives a mobility aware flow rule placement for mobile based IoT solutions, mobile based IoT systems. So, let us look at these three scenarios over here. So, here we have different nodes S1, M1 connected to this particular access point, M2 and P1 connecting to another access point, and their corresponding flow tables are shown here. The corresponding flow tables corresponding to this particular access point and this particular access point at the base station, the corresponding flow table is given over here. Very easy to understand this part. Now, let us say that the nodes M1 and P1 have interchanged their positions. Let us assume a very simple scenario where M1 and P1 have interchanged their positions, and the current situation looks like this. So, essentially what should happen is we will have something like this. Another flow rule has to be added in the flow table corresponding to this particular access point and the base station in this particular manner. But at the same time, we also know that flow table spaces are very limited. So, we cannot simply have these flow tables grow with the addition of these flow rules. So, what essentially has to be done is the scenario like this. So, how can we do it? This is what MobiFlow talks about. So, MobiFlow gives a proactive rule placement scheme depending on the user's movement in the network, and when we talk about such a scheme, what is very important to have some kind of prediction of the location of the end users at the next time instant, given the data of how the user was moving till a particular time instant, and then placing the flow rules at the access points which can be associated to the users based on the predicted locations. Location prediction, this is done in MovieFlow using something known as the order k Markov predictor, which basically takes the last kth location instances to predict the next location, and the flow rule placement, which basically is a linear programming based solution that is used to select which access point is going to be the optimal one. So, for further details, the reference of MovieFlow was given 2016 Globecom paper, and if somebody wants to have more insight about how MovieFlow works, so one needs to go through that particular paper. But I would like to summarize by giving a summary of the results of comparison between MovieFlow and the conventional solution. So, what we have is, with respect to message overhead and energy consumption, MovieFlow performs better compared to the conventional network, conventional solution, and this is quite evident from these two plots. So, control message overhead and energy consumption can be minimized significantly using MovieFlow compared to the conventional rule placement schemes. So, next we have to take care of how to perform rule placement at the backbone network. So, the existing rule placement schemes for wired networks can be used over here, because most of the backbone networks are have a topology and the structure, the overall architecture is similar to that which exists for wired networks. So, we can use the existing rule placement schemes for wired networks over here as well for the backbone network of IoT. And the load balancing is an important issue due to the dynamic nature of the IoT network. So, dynamic resource allocation can also be integrated. So, another very important thing that we have to remember in this particular context is the data center networking. So, there are two types of flows that occur in data center networks. So, data center networks basically, here we are talking about implementation of data center networks with the help of SDN. So, typically two different solutions of adoption of SDN in data center networks. So, here we have typically two types of flows that are observed. One is the mice flow, which are basically small flows, and the other one is the elephant flow, which is basically large scale flows where big volumes of data are coming, big sized data are coming, and so on, and small flows, mice flows, where small sized data are coming. So, here what is suggested is, for the mice flow, wildcard rules can be placed to deal with these flows, wildcard rules, and for the elephant flows, what is required is to have exact match of the rules. So, we need to classify the flows before inserting the flow rules at the switches to adequately forward them in the network. So, if it is an elephant flow, we have to have exact match. If it is a mice flow, we will go for a wildcard match. Anomaly detection can also be performed in IoT network using SDN or OpenFlow. So, here it is required to monitor the network through OpenFlow to detect any anomaly in the network, and which can be done by monitoring each flow in the network. It is also possible to collect different port statistics at the different switches, and thereby from these statistics anomaly detection techniques can be implemented and different anomalies can be found out. Now, what is required is to experiment with these wireless networks. So, what are the different platforms that are available? So, Mininet traditionally did not have any wireless support, but recently there is this Mininet Wi-Fi that is available, which can be used to deploy a network. Support Mininet Wi-Fi can help support both wired and wireless network. Wired implements the Ethernet protocol, wireless implements the 802.11 class of protocols. So, this is one platform that is available, Mininet Wi-Fi. The other one is the ONOS platform, which can be used to place the controllers. ONOS basically helps in placement of the controller. So, it helps to solve the controller placement problem. So, again to sum up, SDN based solutions are useful to deal with different challenges present in an IoT network, and in the first part of it we talked about IoT in the context of sensor networks and small powered, small devices, small IoT devices, and in the second part we talked about IoT in the context of mobile networks, mobile devices and so on, and we have talked about 3 different solutions. One is the UV flow, MOBI flow and the ODIN. These are the 3 different solutions that are available presently to support SDN for mobile IoT networks. So, there are different issues of interference and mobility management which have to be taken care of in these SDN based approaches to IoT. So, interference is a very common thing, a very important problem that has to be addressed. So, and mobility as well, because mobility is something that occurs in any IoT network and particularly the mobile based IoT networks. So, with this we come to an end, and we will stop here for the, we have understood that how SDN can be used for implementing IoT networks and making the IoT networks much more efficient. Thank you.